In this video, we're going to learn how to move our player object and other game objects left and right. So if I go to my player controller script, the first thing I'm going to do is create a couple of variables, and I'll make them public so I can test them in my inspector, one for speed and one for jump height. We won't be using this jump height in this video, that's for the next video, and we'll get our character to jump, but we'll be using speed. So there's two ways you can move objects in Unity. One is using the transform component, and one is using the Rigidbody 2D component. Here in my update function, I have a if statement that's running some code if I move right, and another if statement that's running some code if I move left. If you're not sure what those do, be sure to watch the inputs video so you can understand what those blocks of code are doing. The first method we're going to learn is by using the transform component. So my transform object, I called this transform, right? And this transform is just set to whatever game object, sorry, the transform component of whatever game object I attach this script to. So this transform, and I'll be accessing its position. If I go to Unity, here I click on my player, that's what my script's attached to, and I'm accessing this component, this transform component, and that transform component has a position, right? And that position is just storing data as a vector3. If you're not sure what a vector3 is, watch the video on vector3s. Okay, so I'm going to set it to itself, and I'll explain what I'm doing in a bit. Okay, so this line of code that I've done so far, I've taken this transform object, accessed its position, and then I've set it to something. So when I use one equal sign, it means I'm setting something, right? And then I've set it to itself plus something. So whenever you see this equal sign, what happens in the code is it's going to take what's on the right-hand side, evaluate that, and then store it to what's on the left-hand side. So I've taken its current position, and then I've added something called a new vector3. And a new vector3 is just a vector3 method. So watch the previous video on methods and functions if you're not sure what that means. That creates a new vector3 object, right? And a new vector3 method takes in 3 parameters, so 3 inputs. One for the x, one for the y, and one for the z, just like that. And you'll separate the inputs with a comma. So for its x position, I want it to just move by its speed. And in its y position, I don't want to increase anything. And its z position, I don't want to increase anything. Right, so all I'm doing is taking this vector3, so remember the position is currently a vector3, created a new vector3 with these values and added them together. And when you add 2 vector3s together, it's going to add the x components, the y components, and the z components. Right? So I'm not going to increase the y, I'm not going to increase the z, but I'm going to increase the x by the speed. So if I save that, and I go back to my Unity, and I'll so I've set the player's speed currently to 7. It's just compiling. Right. So when I pressed right, you saw it skipped all the way across the screen. Right, so I'm going incredibly fast. And the reason for that is because this lot of code is being run every frame. Remember, what's in the update function will run every frame. And when I press the right key, even though to my human mind, I'm only tapping it, right? These frames are being rerun every 20 milliseconds or something like that. So even though I'm just tapping it, it's probably reading 3 or 4 times. So the way I can overcome that is by multiplying this new vector3 I've created by something called time.delta time. Oops. And all time.delta time is the time in between frames in seconds. Right? Actually, I'll print that to the console so you can see what I mean. Now when I go back and play it, it's moving more naturally. And you can see in the console, right, each frame has been rendered at a slightly different time. So this is being rendered at 0.022, this one at 0.021, 0.026 of a second, 0.066 of a second. So all I'm doing is I'm multiplying that by the vector3 before I'm adding it to the current position. And when I multiply a number by a vector3, all it does is multiplies that same number by each of the x, y, and z. So if time.delta time was 0.02, it'll take that 0.02, multiply it by the x, multiply it by the y, and multiply it by the z. So it just makes this value a bit smaller before adding it on to the current position. Right? And coding follows the rules of maths, so it'll do this multiplication first before it adds it on. And if I copy this now into my left moving code, and I'll play the game again. So I can move left. Oh, so I move right. Sorry, I can move right, but when I move left, I'm still going right. And the reason for that is in my left block of code, I'm still adding on that vector3. I need to subtract it now. I move left and I move right. So that's how you move by using the transform component. Let's try making it move using the rigid body. So I'm just going to comment these out. I'll delete this time.delta time, and I'll comment this out, and I'll comment this out. Okay, so to use the rigid body, I called my rigid body object RB. So I'll type in RB, and I can access something in a rigid body called its velocity. And velocity for a 2D rigid body is what's called a vector2, right? So I'm going to create a new vector2 image object, and a vector2 is exactly the same as a vector3, except there's no z component, so it's only x and y. Vector2, and I have to pass it an x and y, similar to what we did with the vector3. Now, I have to separate that x and y with a comma, so I'm just doing that first. And I'll type in the y component first because we don't want to change anything in the y when I'm just moving left and right. So I'm going to change RB dot velocity dot y, exactly like that. And all that's doing is saying whatever your current velocity in the y direction is, keep that. Right, so it's not changing the y direction, and we'll change the x direction just by putting in speed. So speed becomes your new velocity in the x direction. And if I save that, I'll copy that down for when I move left, and I'll change now my speed when I'm moving left. So instead of saying speed, I'm going to do speed times -1. And what that's doing is just flipping the value from positive to negative. Right? So if speed is currently 5, it's going to move left by -5. Or it's going to move by -5, which will make the character move left. So I'll save that, and I can move left, and I can move right. So that's how you move Rigidbody. To explain the difference between the two methods, I've created this firebolt bullet. How it's moving doesn't matter, but it's just moving with some velocity. And I'm going to drag it down here so that it will run into the player. And I'm actually going to test out the first method first. So I'll comment out the Rigidbody method and uncomment out the transform method. And I'll save that. Now, I've changed my player speed to 73, so he should go forward by a fair amount, right? But I want you to keep an eye on the bullet. Keep an eye on the actual firebolt when I play the game. It's just compiling. Okay, watch the bullet. I wait for it to come close. Come on. So keep an eye on that firebolt, it's coming close, and I've pressed forward. Right, so the firebolt just continued through, and then now watch what happens when I use the Rigidbody. Again, pay attention to the bullet, right? This time I carried the bullet with me. And the reason for that is because when we move by using the transform, all we're doing is skipping the player. So when we say its new transform position is going to be at, say, y equals y plus 5, it's just going to move the player to those new coordinates. It doesn't actually cause the object to go in motion, right? It's kind of like just teleporting it. So when we use the physics or the Rigidbody version, we'll stick to using the physics. So the player will actually carry forth with its momentum in that direction. So in the first way, when I pressed my right key, I skipped past the firebolt, so the firebolt continued to go. Right? That's because my player doesn't actually come in contact with it, it just got teleported to its new position. Whereas in the second method, my player has actually moved towards that position, so it's actually collided with the bullet and then carried it with it. Okay, so that's all for this video. In the next video, we'll get our player to jump.